Hi, good morning. Thanks so much for joining me here. There's only 2 days left in 2022, and this is one of them, and I'm going to spend part of it looking at this radio. This is a pretty nice looking big light radio with very sharp corners. I usually don't see them with such a sharp shape to them. So wonderful. Got its knobs, all these push buttons. Has kind of a neat look to it. Square as can be. Look, a handle on the top. Wow. And the back is also, it's not the cardboard stuff, it's that. Philco Model 24, code 121. 115 volts, 30 watts, 25 or 60 cycles. Printed in Canada. So it's a Canadian-made Philco radio. Just an AM band. Pointer moves. On-off switch. Buttons seem to stick in. This one has the word dial under it, so I'm guessing you have to push this button to make the dial operate. That's probably a pretty good guess. Well, isn't this great? Now, if you can look through the slot here. Oh, there's more in there than I realized. So up on the top there are all the adjustments. Those are trimmers for the push buttons, and I'm guessing this is a screwdriver slot. I didn't realize that. So you can adjust these without taking the back off. That's the screw to a wire antenna if you want one to come out. And it's hard to see, but just inside is the antenna, and it looks like a basket antenna. Which is maybe why this is this thick. Very cool indeed. Now, I took some time to look for a schematic for this radio. I could not find one on the internet. Doesn't mean there isn't one. But I pulled out my only RCC book I have. I have one RCC book, Radio College of Canada book. These are fairly common here in Canada. These books were created by a college called the Radio College of Canada. It was a private school. Operated from the 1930s right up until about 5 or 10 years ago or so, and then it was bought out by a large Canadian university, York University, I believe it was. Bought the school out. Up until then, it had operated as a private school, and one of the things they did in this school is they produced schematics of the radios being manufactured here in Canada. And I believe, I may have the story wrong, they would acquire a radio model of all the new models from the radio manufacturers, who I guess would just provide them to the school. And then students would disassemble them or whatever they did to them to figure out the schematic, and then they would produce schematics. And that's what this is a book full, and you've seen these. Well, if you've done a Canadian radio, you may have seen these on the internet. There's many. I have an electronic version of all these. So this particular book, 1939 to 1940 series, Radio College of Canada Circuit Manual is what they called it. And it just lists the manufacturers, Canadian General Electric, model number, and then what page in here you would go to, or what sheet number you would go to in here. A radio repair shop would have a library of these. Well, I guess one for every year. So really that many radios being, like this many brand new radios being made in Canada? A23, I've done one of those. I can't imagine that this is, this many radios were being made. Let's see, there's a number here. So you see numbers like 92, 97, 100 radios. Do you think there were 100 different radios manufactured in Canada in that year? Well, I don't know. It seems like an awful lot to me. One manufacturer producing 40 different radios? I don't know. Well, in any case, what are the chances that this radio schematic can be found in this book? And the chances are good, or I wouldn't be showing this to you right now. So, but I was surprised. So we look over the index. Look down the index. Northern Electric, Majestic, DeForest, Marconi. These are all Canadian factories producing radios. Philco, Model 10, 12, 14. Doesn't that sound like one of their very first models? Wouldn't that be a lot older than this book? Come down the numbers. 22, 23, 24. There it is. Model number 24. Page 81. Or sheet 81. So we'll find sheet 81 here. Just before we look at the schematic though, let me just mark it with this. Take a look at this. So this page was in this book. Ferguson Radio Service. Ferguson is an area, or is there a town? I think that might be a town called Ferguson. I'm not sure. Meaford, Ontario is the name of the town. Leslie J. Ferguson. Okay, so that's his last name. So Ferguson is the last name of the fellow here, proprietor. Phone Meaford 288. His phone number has 3 digits. All types of radios serviced and repaired. Service you appreciate. So this, no doubt, this book has come from this repair shop, this owner. And this is one book. Why I don't have them all? Someone gave me this book. Why they didn't have them all? Why they have just one? No idea. And here we could assume Mr. Ferguson or one of his employees, if he had employees, developed this sheet for a Philco, 1841. Interesting stuff. If he did this all on his own by looking at the radio and extracting all this by examining the circuit and figuring it out, oh wow, there's a chance he borrowed a sheet from somebody and he hand copied it because he couldn't run it through his photocopier. There were no photocopiers. So let's take a look at this. Sheet 81. Now the first thing is there's 2 models on this page, Model 25 and Model 24. There it is. Alignment data on data sheet 83. I have to go to another page to see the alignment data. It's the very next page. There it is. Model 24 with a bunch of other models on this page. So we have the alignment data and we have the schematic for it. The IF is 460. This was made in 1939. So just at the start of the Second World War for us here in North America, perhaps we could say. Or maybe it was the start of the war for Canada. The Americans may not have been in the war yet. I don't know my Second World War history that great, but you could think of this as coming out at the end of a manufacturing period. Actually, this is at the end of the recession, isn't it? So I don't really know what the state of affairs were with all this stuff, but that's the time when it came out. There's a location of compensators, what we would call trimmers and other alignment adjustments. Schematic diagram. Model 24T. There's a T there. Under that, right above my finger. T for Toronto. Toronto is where this was made. So I'm pretty sure the T stands for Toronto. And we see the push buttons here. We see the antenna here. 1, 2, 3, 4, 5 tubes. Okay, so this one's the rectifier tube. The power supply. See, the heaters are in series. No transformer in the power supply. There's the plug. No transformer. So this is a transformerless, basically 5 tube, 1, 2, 3, 5 tube radio. The mixer tube is right at the front. There's no RF tube. It has 2 IF transformers with an IF amplifier in between. That's the detector, first audio amplifier, very typical radio circuit. Output tube, output transformer, speaker. There we are. Pretty typical radio. Okay. So as far as I know, this is the only, well, for me right now, that's the only schematic that I have, but I have one. Going ahead with the radio without the schematic is a bit of a gamble. So, my usual way of approaching these is to take the chassis out and take a look at it, see what's happened to it before plugging it in. We can actually start by looking at this cord. First thing I notice, you see how nice and sort of floppy, flexible the cord is? So this, I believe, is a natural rubber cord. I believe. Here it is, you know, so 1940, now it's 2020. This is a 80-year-old radio. This could be the original cord. May not be, but it just gives me the impression it is the original cord. And look at it, it's flexible. Look at it for some cracks. So the cracks are starting up in here, but they have not gone through. Just up the light in my office here, or my shop rather, a little bit. Okay, so I turn the light brighter, but the camera compensates, so it doesn't look much brighter to you. It's brighter to me. And I'm just looking for any damages of significance on the power cord. Well, it's really crushed right in here. Really, really crushed down. How did that happen now? I mean, it's really crushed. And it could even be a little bit of copper showing right there. Okay, we'll keep that in mind for now. Now, how to take this guy apart here. I guess we got to take the knobs off the front. Looks like a crack in this knob here. Oh, just come right off. Easy as can be. So I'm looking for cracks in it. Hard to say. Looks like the dirt is staining some cracks. They seem pretty good. Those are the original knobs though. That's great. Okay, and there's a note on the top. It kind of just hums. It just hums. Let's get this note off. I would not recommend taping anything like that. Okay, it's come off fine. Because this is a Bakelite, and you see it's still very shiny on the top. It's probably just got a layer of dirt on it. My own personal view of these is this is a great material. Doesn't seem to seems to last for a long time. Maybe better than regular, plastic. It's a little bit bowed out here, it looks like. Cleaning these. This one's quite clean. What I will do with this one is I'm going to clean it just with water. I'm not going to do anything else to it when I get around to that. Just water and a cloth. I would not try anything else. If you remove the shine is a thin, this is my understanding of it. The shine is from a very thin layer on the top. The material itself is a combination of a word I can't think of right now. A thick gooey material. a thick wow, I just can't get it out of my mouth. A thick gooey material and wood fiber, and it makes it very strong. That's my understanding of what Bakelite is. It's been pressed in a mold, and it develops a surface on it. It doesn't develop, I guess. When you press it in the mold, you get a surface like this. If you clean this too vigorously, you'll begin to reveal or free up the fibers that are in it. And once that happens, it's all downhill from there. So, to preserve these guys, do the least. That's kind of where I would go with this. You notice it has the dial tag in it. No one ever put the other tags in for the different stations that these might be tuned to. So I guess it spent its whole life with just blanks here. It's got some screws here you can hardly see. And I'll bet you it's got some screws underneath. Oh, there's some writing here. B16977. Somebody just really crudely scratched that in there. Shame on them. What is this number? I don't know. This is Hamilton. DM? I don't know. This is a little odd how this is done. This screw is holding a little metal bracket here, which is going up, and then this screw is catching the bracket. It looks like there could be a screw missing here. What is holding the radio in? Well, these could be doing double. They look like they're doing double duty. I can see it going up into the chassis here. So this is holding the chassis. This screw is just probably missing. Yep, there's a place where you could put a screw in there. It's missing its front screw. Looks like if you take these back ones off and then did these two up here, this whole back would lift off. But I think what will come with it is the antenna. So let's see what happens here. I'm sure there was a time where people looked at big light radios and went, "Who wants that junk in your house anymore? Give me a brand new hydrocarbon plastic radio." The wonder material. These screws, when you're putting them in, not too tight. These are done correctly. Don't screw them in tight. You'll set the stress into the materials here, especially in corners and other. And you're going to crack. It's going to crack. You don't want to crack it. Okay, I think the back's going to come off. It's leaving the antenna behind. It's leaving everything behind. It's just come right off. Look at this antenna. Oh my gosh. Somebody find the engineer who came up with this. Holy smokes. Never seen anything quite like this. Oh, look at it. What do we got happening here? We've got this inside coil. The wire is woven in this coil. Then we have this, like these wires coming up here. And they go over top of this form and down the back. I can see them in the back. This is the strangest antenna I've ever seen. I've never seen one like this. So basically, this inside antenna is contained inside this network of wires. Look at this wire. It looks like it's been repaired here. Looks like it's been twisted up right near the screw. What is happening? So this says antenna, so this would be for, you know, an extended wire. And it says something down here. What does it say? It says, to change tubes, remove both nuts. Oh, it sounds painful. I don't know. Do you really have to do that to yourself? Both nuts. Remove both nuts. They didn't say screws. Remove both nuts. This and this. There's not a nut there, but there's a screw there. It doesn't quite look right. Is that what they're talking about? Remove this nut? Is that how this wire got broken? Somebody got carried away on the nut removal? Why would you want to remove those nuts? Don't you want to remove these screws? It says both. Remove both nuts. So I guess the idea is you don't want to take the chassis out to change a tube, but you got to get this thing out of the way. So you need to remove your nuts before doing the tubes. Maybe that's a basic rule. before doing any tubes in a radio, always make sure your nuts are gone. Okay, let's do these. So now my question would be, has anybody else done anything to this radio aside from scratching Hamilton into it? General Electric had a large radio factory in Hamilton. Hamilton's a very industrial city known for making steel. Has a large steel mill. Had two of them. Philco and Difasco. I don't know if they are both still operating there. This looks like a new capacitor popping out here. Okay, Mr. Radio, are you going to come right out? Just going to come out? And the answer is yes, it's going to come out. Oh my gosh, what's happened here? The whole edifice has come off here. Wow, this makes it easy to clean this guy right up, because everything that could be damaged. Hey, look, there's a date. October 24th, and then we can't read the year. October 24th. Well, that's too bad, the year disappeared. Oh, wait a minute, it's over here too. October 24th. Wait a minute. It's like a mirror image. Like the guy's stamp wasn't working right when he stamped that in there. Looking for cracks or anything else I should spot. Big piece missing right in this corner here. That's kind of odd. How would that go missing? Somebody jamming the radio in? You know, the plastic piece is fallen off too. The dial plastic covers here. It's gone yellow. Probably some of that is on the surface. Oh, Zunite. Okay. Let's take a look at this radio now. Right away, it's got Loctol tubes. Oh, look how lovely the front of this looks now. It's out of the out from the yellow, out from behind the yellow. It really does take the edge off, doesn't it? Very cool. I love the Art Deco sort of look of it. Fantastic. One light here. Some more pencil writing here and there. Probably during the manufacture. So it's got Loctol tubes. So these tubes, I think they were popular for a short time. I'm going to have trouble getting it out because it's a Loctol tube. It's not going to come out easily. There we go. So these ones, I have a, if you haven't seen one of these before, I have this, I don't know what to call thing on the bottom that goes in and snaps in. So they're held in place. So these make very good tubes for car radios. And you see the pins are all much smaller now. And the key is still done the same. The key's right there. And the numbers, so it says right now, Loctol, Philco, made in USA, Loctol. Maybe it was a Philips thing. When renewing, insist on genuine Philco tubes, of course. The numbering is unusual. The numbering starts with a 7, even though these are not 7-volt tubes. Pretty sure they're all 6-volt tubes, but I could be wrong about that too. Because how do you get, these are in series according to the schematic we looked at. That's a 35A5, 35Z5, so there's 70, 35Z3 here. Let me put this one back in before I get them all mixed up, because this other one looks interesting. Pop. This one's got a big sticker on it. Let's see what this says. This is the rectifier tube. Marconi Radiotron guaranteed by Reed and Campbell. Sold Young Street. That's probably the phone number. HY1109. That's probably their phone number. Sales and service. They put a serial number on it, and they didn't date it. So what's going on here is that people were buying vacuum tubes that didn't last long in their radios. And they would be upset. They'd say, I paid you a good buck for that tube you sold me, and 2 weeks later it's not working again. So the manufacturer, the seller, the retailer would want to maintain their customer relationship. Whoa, okay, give me back the old tube and I'll sell you a new one, and I'll knock a little bit off the price for the new one. And so what would happen is the sellers would put a date mark on the tube, so when you came in with it and said, this tube only lasted 2 weeks, they could grab it and go, no sir, I sold this to you 2 months ago. You got 2 months out of this tube. But I tell you what, based on 2 months, I'll knock down the price of a replacement. How about we do that? And it would come with a sticker on it. And I'm sure that also the sticker is kind of suggesting come back to the Reed and Campbell to buy your next tube. Now, Young Street is Young Street is the longest street in the world. It actually goes by here in Aurelia. I'm 100 miles away from Toronto. And continues on. I think it's 1,100 miles long, which would be 1,500 kilometers or so. Young Street. There we are. That's the story. Read on the tube. When renewing, insist on a Philco tube. I must have a Philco tube. I'll put that tube back. Pretty sure these are all going to be in the right spot. 1, 2, there's one hidden. Oh, no wonder. You've got to get this antenna off to get at a tube that's way up in there. So I have a good number of these 7-volt Loctite tubes. This is falling off of somewhere. So I'm not too worried. If some of these are bad, I'm sure I'll be able to replace them. Now, has anyone else fooled with this? Can I tip this up? I can tip it up on this end, but not on this end. So we'll tip it up this way. And we'll look in there. Oh my God, it's packed. But I am not the first person here. Oh my gosh. I see some pretty horror. Oh, it's a horrible thing. So the Philco radios I have done have been kind of like this. Packed. Just packed with parts. Oh my gosh. Well, we see this guy. This is not original by any means. This is a replacement. You can see where the connections were made here. He's had his big Hummer replaced, yet there's a note on the top of the radio that said, just hums. We could put that right on this capacitor. Just hums. Okay, no one's really done anything, and look at how everything is just kind of squished in there. Well, something that really jumps out at me is this capacitor here. What is going on with it? It appears that its guts are leaking out one end here. Like the guts have slid out. That's what it looks like. You know, that would be the cardboard sleeve. That's the edge, and then guts. So I don't think this is a radio we necessarily want to try turning on until some more work has been done to it. I don't know about that. I do like energizing radios as soon as possible. So here we get a closer look at this power cord here. Wow. Looks like something was sitting on it. Now it could have been the radio. The radio was sitting on its own power cord for And it may have had stuff piled on top of it and a lot of pressure coming down on it. It may have sat somewhere for, 30 years for all we know. Who knows? It's probably still serviceable, but sure looks like copper coming through here. Probably not a short circuit in it. But wow. And this is going to be the original cord, I'm pretty sure. Although there's a joint right here. Well, there's a protector right here. I don't know that it's a joint. The other wire looks pretty continuous. So flexible. Unbelievable. The rest of these wires won't be flexible, though. The rest of these wires are going to be as hard as rock. There's no flexibility in any of them, which is another thing that makes working on these radios really difficult. You try to fish your way in deep, you move these wires a little bit, bad stuff starts happening. And you end up in a jackpot. There's a little cap on this. What's it holding? Does it come off? I don't know if it will come off. Probably a coil inside there. No, not going to come off easily anyway. It's got a check mark on it, so it's okay. Well, it hasn't been on fire. That's about... yeah, it has not been on fire. Not yet. Maybe I can set it on fire here. What do you think? Should we just plug this in and see what happens? I'm very curious. Always curious about this stuff. There is no transformer here to be shorted out, but you could easily have a short in here somewhere else. Who knows where, but something could be shorted. Well, I'm going to stop for a few minutes. Oh, let's look at the push buttons on the top and the tuning scheme. Whoops. Getting a little tangled up here. I just gotta wonder, is this antenna, is this what we need today? Is this the antenna of the future? They market this radio with a comment about interference from your modems. This radio is designed to avoid modem interference. So here's all the adjustments. Now it's only 1, 2, 3, 4, 5 buttons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 adjustments. So it's got to be 2 per. The tuning capacitor has a large side and a small side. So that tells me they probably aren't patterns. So probably what's going on here is one adjustment is the local oscillator, and the other adjustment is the front end tuning. So you're doing 2 adjustments for every button. Not too much else to see. This isn't held on very tightly. What's the story here? Did I loosen this up when I took it out of the cabinet? Was it loose like this already? It's got a funny rocking motion. I'm trying to figure out what it's rocking about. I don't know. It looks like you could remove this and then you could just take this whole thing and just throw it back. Is there piles of wire coming down from it? No, it's just this one wire here. And is that it? One wire? Really? One? Oh no. No, there's a wire under here. Okay. Should we turn this guy on and see where it's at right now? Because I get a kick out of doing that. Well, to give a little bit of time for my brain cells to talk and discuss this question. And then we'll see what my brain comes up with in a few minutes. I'm trying to decide if my cat's going to let me do this or not. Peanut, can you wait 5 minutes? 5. What do you say? Not sure he was agreeing there. 5 minutes, that's how long it'll take to turn this radio on and see what happens. Now, I wouldn't plug this in a regular outlet and switch it on. That would not be the wisest thing. It's switched off. This radio has no transformer. There's a good chance it has a hot chassis situation. So, bearing that in mind, I'm plugging it into an isolation transformer. It's actually coming through this voltage control device here and through these 2 light bulbs up here, which I'm going to make sure they're both in. Yeah, so I have 2 ways to restrict the power. One is I can turn down the supply voltage from 120 down to something quite a bit lower. And the other one is I can utilize these dim bulbs to restrict any fault current that might want to flow if there's a dead short in this guy. So first we're going to apply power and with the switch off and make sure nothing happens. Here we go. Okay, so we're sticking 111 volts on the plug here. The cord itself, even though it's damaged, obviously doesn't have a short in it, or these 2 lights would be on full tilt. We're going to cut the power, turn the switch. A couple things should happen. This light should kind of flash on a little bit. These lights should do the same. They should kind of come on and then go down. And then they should come up again. And when they come up again, the radio should start making noise. That's the pattern we're looking for. Here we go. So this light came on, but whoops, flag incident. These lights didn't come on. Okay, just drawing so little power it wasn't enough to trigger these 2 lights, I guess. Here comes the hum. Now we're going to try to listen through the hum. Nah, we're probably not going to listen through the hum here. No. Well, they're right. It just hums. Okay, well, that usually indicates the power supply filter. Let me pull this out of here. The power supply filter capacitor is no longer filtering. That's usually what it means. This replacement one needs to be replaced again. That's what you could reasonably conclude from that test. Just a little bit surprising to me, but when was this done? This could have been done. This looks like it's from the. Well, if we're going to be replacing it, I might as well pull it out of here. It's possible there's a charge on this right now. I don't think so, though. Can I put this right upside down? No. What if it falls further? It doesn't go anywhere. 40 plus 40, 160 volt. 40 microfarad, 150 volt DC there. So say 160 here, 150 there. Maximum ripple, 110 milliamps. I've never seen that rating. Yellow is 40 at 150. Yellow. Red. Red and yellow. They're both the same. 40. Oh. The red one's good for 160. The yellow one's good for 150. Boy, they're kind of splitting hairs there, aren't they? Black is common. Cannot isolated. Cannot isolated. Can. Not isolated. The can. Okay. So they're warning, because they know these things are going into hot chassis radios and stuff like that, that the can itself here, which is covered with this blue covering, is connected intimately to. It is part of this black negative return lead. So I just got to replace this, and that'll probably make the hum go away, and we can try the radio again. Okay, I'm going to replace that. Okay, I've got two new 47 microfarad capacitors installed, 160 volts each. Let's see what happens now. My guess, radio's going to work. Let's tuck these inside here. Okay. Let's see what happens. It could be lots more wrong. I mean, who knows for sure what's going to happen. Okay. Switch is on. We're going to use the dim bulbs. Here we go. Good. Nothing bad happened. If these lights had come on full tilt, it would have told me I put those capacitors in backwards, or some other dumb thing would have happened, but no. Okay, a little volume. What do we get? Should make sure this button is depressed here. Let's go tuning. Look at that. Okay, so the strongest AM station is right around here at 590. Oh, we don't have full power here. It's running on 100 volts. $110. Okay, let's go 90 degrees. Go this one. Well, it's largely working. It's just not picking up any stations. Let's give it a little bit of a boost. So this goes to an outdoor antenna, the status of which I am not sure. That certainly works. Oh, blew the radio up just like that. Blew it right up. What happened? What happened there? It's a different radio. So all I had to do was scare it with an outdoor antenna. It got busy. What exactly happened there? I don't know. I don't know. But there we are. Wow, that's good. Right around 590. Directional. Yes. I think this antenna is probably doing something quite special. That's very good reception. That's very good. reception's very good. Okay, a real tough station is up here at 860. French. That's French. Okay, that's enough for now. Wow, just with changing the power supply capacitor, leaving everything as is. Look at that. This radio is back in business. And the last guy in there, that's all he changed too. He did exactly what I did, or I did exactly what he did. Fantastic. We should test this capacitor and then call it a day here. Now, of course, having this on the radio and hearing the hum and replacing it and having the hum disappear, that's actually kind of a valid test. Am I going to be able to do that? There's one. There's the other. Let's give this guy a little bit of a test over here. Now, electrolytic capacitors are not like regular capacitors. Now, there's a powerful statement. So, in order to test them for leakage, they all leak a bit. I have to flip this button here. You're now ready to test an electrolytic capacitor. Put the negative lead to the negative side. I don't have enough experience to really call it from experience with doing this kind of capacitor. But let's see what happens. We're going to put 50 volts on it. The eye here, which you can see is open at the bottom, will close and then it will open as the capacitor charges. Look at that, it just popped right open. Like that. That's a little odd. Let's go with 150 volts here. That's a little odd. I think that's suggesting there's no capacity left in this. Let's try the other one. 50 volts. Same thing. It's just, you would expect it, especially with electrolytic, to close and then as it charges open again. I'm talking about the eye here. So again, I don't have a lot of experience. It would appear to me that this is suggesting there is no capacity left in this unit. Let's give it another test. Use a different tester. Now, I often find these old capacitors that are leaky fool testers into thinking they are good. Really good. In fact, better than their rating. So they tend to show a high, unreasonably high capacitance. Okay, what do you say? Nanofarads. Nanofarads. Come on. This is supposed to be 40 microfarads. There's no capacitance left in here. It's almost as if the leads have separated, maybe the negative lead has separated inside from the capacitor itself to give these kinds of readings. It's a dud. Doesn't work. Okay, well that's great. So, am I going to do more to this radio, or am I pretty well done? Because it's working so well. I mean, anything I would do would just take it downhill, wouldn't it? I don't know. I'm going to think about it. We'll see what happens tomorrow. Thanks a lot for watching. I hope you enjoyed that.